Hi students, how are you? So I will continue the next part of this acids, bases and salts. In the previous class you have learned the importance of pH, isn't it? So I will continue the same. So how the salts are formed? Normally the salts are formed by the action of acids and bases. Okay, if an acid combines with a base, then salt and water are formed. Which reaction it is? It is a neutralization reaction, isn't it? Okay, good. So first we will learn the about some salts. This salts of sodium, salts of potassium, salts of magnesium, salts of ammonium. Let us say these salts we will learn first. Okay, we call them these sodium salts of families and potassium salts, magnesium salts, ammonium salts as their just indicate like a family of the salts. Okay, sodium family, potassium family, magnesium family, ammonium family, or chloride family, or sulfate family, or nitrates family, like this. Okay, let us take first the sodium family. That means sodium chloride, sodium nitrate, sodium phosphate, sodium oxide, sodium carbonate, sodium hydrogen carbonate, like that. Okay, if you take the potassium also, potassium chloride, potassium nitrate, potassium phosphate, potassium oxide, like that several potassium salts. Okay, next magnesium, like that, magnesium chloride, magnesium nitrate, magnesium phosphate, magnesium oxide, magnesium carbonate, magnesium hydrogen carbonate, like that. Understand? So ammonium family also, ammonium chloride, ammonium nitrate. So let us see ammonium phosphate, how these ammonium salts are oxide formed. Ammonium normally carbonate. Acids, if these are all the different families of the and different sodium, potassium, magnesium. From these salts are ammonium. And you are you can take the strong acid and a weak base, weak acid and a strong base, like that, a combination. Okay, let us see the one by one. Okay, first the potassium sulfate. Okay, the formula is K2SO4. Okay, it comes under potassium salts. So how it is formed? By a strong acid KH2SO4 and a strong base KOH. Then the potassium sulfate is formed like that. Sodium sulfate formula is Na2SO4. It comes under sodium salts family. And how it forms? Again, a strong acid and a strong base, H2SO4, sulfuric acid, and sodium hydroxide, NaOH. Okay, like that. Calcium sulfate. So it comes under which family? Calcium salts family, isn't it? And formula is CaSO4. And how it is formed? By the action of sulfuric acid and calcium hydroxide. Okay, next magnesium sulfate, MgSO4. It comes under magnesium salts. Okay, which family? Magnesium salts family. And acid base, how it is formed? By the action of sulfuric acid and magnesium hydroxide, isn't it? So next what we see, sodium, like that, copper sulfate, sodium chloride. Okay, and sodium nitrate, sodium carbonate, and ammonium chloride. How they are formed? Yes, you can continue with by one by one. One by one you can continue, no? Okay, take time for 2 minutes and observe. Okay, have you observed? Right. Then I will ask you one question. How the sodium nitrate is formed? It formed by action of, yes, okay, HNO3 and sodium hydroxide, isn't it? Nitric acid and sodium hydroxide. Good. Okay, now we'll see how these are formed and what is the pH value. Okay, when you take a strong acid and a strong base, you will get a pure neutral salt. Okay, when a strong acid and a weak base, that means acidity strength is more and basic strength is less. So automatically you will get acidic salts. Acidic salts means less than, pH value will be less than 7. When you're taking weak acid and a strong base, that means strength of a base is more. That automatically pH value will be more than 7. Then we'll get the basic salts. Let us take these values, okay, and just identify what you have to do is you have to identify which one is a neutral and which one is the basic salts and which one is acidic salts by your observation. That means when pH value will be less than 7, then it is acidic salt, and pH value is more than 7, then it is a basic salts. You have to identify, that is your work you have to complete. Understand? Good. Just observe and find out, write down in your notes which one is a acidic salt, which one is a basic salt. So what you have to do? You have to classify these salts into acidic, basic and neutral salt based on the pH values. Understand? So observe this table very carefully, and already you know which are the strong acids, which are the weak acids, which are the strong bases and which are the weak bases. Already in the previous sessions you have learned it, isn't it? So you have to classify their acidic and basic nature of the salts by observing this table. That is your work. Okay, this worksheet you have to do as a worksheet answers. See this diagram. Can you identify this? These are the salt or sodium chloride crystal salts which are formed in the meadows from the seawater. Okay, this seawater will be allowed to dried up for several weeks. Then you will get a rock salt or sodium chloride crystals. Okay, then we'll see again about the salts. So how the salts are formed? By the neutralization reaction, isn't it? They are the ionic compounds. Salts are ionic compounds, means they will have a positive ions and negative ions, Na plus and Cl minus, and their charges are equal and opposite. Their charges are equal and opposite. That's why they are electrically neutral. That means their charges are equal in opposite. So electrically they are neutral. Okay, then we'll discuss about the common salt. Okay, how the common salt is formed? Normally the salts are formed by, what is the neutralization reaction? The acid combines with the base, then the salt and water are formed. You know already, you should by heart this. Okay, and what is the reaction? HCl combined with sodium hydroxide gives rise to sodium chloride and water. So HCl plus NaOH gives rise to NaCl and H2O. It is the neutralization reaction. Then if a strong acid, here a strong acid, what is a strong acid here? HCl combined with a strong base. What is a strong base here? NaOH, to form a neutral salt, NaCl or sodium chloride. Okay, here any salt which is having replaceable hydrogen. That means if the hydrogen can be replaced, then an acidic salt is formed. In the opposite, any salt that contain replaceable hydroxide ion, then it is an basic salt. Understand? So replaceable hydrogen, it is an acidic salt. Replaceable hydroxide ion, and it is a basic salt. Understand? Good. Now we will go in depth about the common salt. Okay. What is the common salt? Sodium chloride. What is the formula of the common salt? NaCl. Okay. How it is formed? Already I learned sodium hydroxide combined with HCl to form sodium chloride and water. NaOH plus HCl gives rise to NaCl and H2O. Okay. It is normally the most common among all the salts. Okay, and the rock salt is a large crystals, often brown in color, because sometimes the impurities are mixed with the rock salt, because of the just simply take the seawater into the meadows and evaporating. So after some time, this seawater, already seawater is a lot, contains a lot of impurities, and this sand or water, this soil will also mix with this rock salt and forms a brown color. Large crystals will be formed, normally slightly brown, not exactly brown, and slightly brown. Okay. Then when the sea of the bygone ages dried up, it forms the mines of the rock salt like coal. What it means actually, see, thousands of years back, if you taken this Mount Everest, okay, this mountain Himalayas, okay, how it is formed? Earlier it is a sea, okay. Then this sea, air mountains are evolved from that sea. Then what happened to that? All the this water, sea water, they will go into the earth as forms a layers and forms a, it becomes hard and becomes the dried up, all this water will be dried up and forms a the rock salt mining, like coal mines. The rock salt mines are also present. Okay. Okay, like that also the rock salt is present, formed. Okay. And how to prepare this different materials like sodium hydroxide, baking soda, washing soda, bleaching powder? For all this, sodium chloride is a main raw material. What is the raw material? To prepare any product, we require some raw materials. Okay, some materials which want to find the product. So the reactants, or for a reaction, the reactants or the pre-material which required to make that material, we call this as a raw material. The sodium chloride is a main raw material in preparation of all this sodium hydroxide, baking soda, washing soda, and bleaching powder. We will learn one by one. Okay. And most of the seawater also contains the sodium chloride. Okay. And these deposits, okay, are found in several parts of the world. In the entire world, so many deposits of sodium chloride is present. Okay, then what is it a neutral salt or acidic salt or a basic salt? It is a perfect neutral salt. Then what is the pH of the neutral salt? It is, pH is always, neutral is 7. Okay, it is exactly on the middle. Okay, then if you taking this sodium chloride and dissolve in water, okay, so we call them as aqueous solution. What do we call them as? Any salt dissolved in water, we call them as aqueous solution. The aqueous solution of sodium chloride is also called brine solution. It is an important bit you order, students. Okay, aqueous solution of sodium chloride is called brine solution. So from this brine solution, you can prepare the sodium hydroxide, baking soda, washing soda, bleaching powder. Like this, so many materials can be prepared. We'll learn one by one. First, we'll learn about the sodium hydroxide and its how it is prepared and what are the uses. Okay, sodium hydroxide, what is the formula? NaOH. Okay, how it is prepared? A process called chlor-alkali process. Very easy to remember, chlor-alkali process. Okay, then here sodium chloride is taken, aqueous sodium chloride. What is this? It is the brine solution, isn't it? Take this brine solution and add some water, and by passing the electrolysis of this sodium chloride when combined with water, and under the electrolysis process, okay, that means passing the electricity through it, you will get a sodium hydroxide. Sodium hydroxide is an alkali. Remember, already you might have learned all alkalis are bases. Okay, and this sodium hydroxide is also an alkali. Okay, alkaline substance. And chlorine is also formed. Okay, chlorine gas and hydrogen gases are formed. How? By taking this sodium chloride aqueous, that means brine solution. If it is undergoing the electrolysis, then we will get the sodium hydroxide, chlorine and hydrogen gases. So what are the products formed in the chloralkali process? That means sodium hydroxide, hydrogen and chlorine. What are the reactants? What are the reactants? Yes, sodium chloride and water. That means aqueous sodium chloride. Okay. So how it is prepared? It is prepared by passing the electricity through brine solution. How it is prepared? Yes, passing the electricity through brine solution. Okay. Then automatically what will happen when the electricity is passing through the brine solution? Brine solution is an electrolyte, and it will decompose and forms the ions. Okay, positive ions and negative ions. They will be formed near the anode and cathode. Okay, and what is this process is called? Chlor-alkali process. What is the where the sodium hydroxide is formed? It is formed on the cathode. Okay, cathode. Understand? So it is a negative electrode. Cathode is a negative electrode. Okay, so sodium hydroxide is formed at the cathode. And now we'll see what are the uses of the sodium hydroxide. It is already I told you it is used in the preparation of the soaps and detergents. So what is the soaps? Soaps and detergents. The sodium stearates. Sodium stearates or potassium stearates are the soaps and detergents. Okay, so in the preparation of sodium stearate, this stearic acid will be combined with sodium hydroxide to form a sodium stearate. It is a soaps. Okay, in the preparation of soaps and detergents. And if any grease part we want to remove from the metals, then this sodium hydroxide is used. So it is used as a degreasing the metals, and it is used in the paper industries also. Okay, paper making industries. Okay, to make this pulp react with the sodium hydroxide. Okay, so in the paper making industries also it is being used. And you might have learned in the 8th class preparation of rayon. Remember, preparation of rayon. Okay, what is rayon? Artificial silk, isn't it? In the preparation of viscose, the sodium hydroxide will be combined with carbon disulfide. Just remember once, just recollect your 8th class. Okay, you have learned, isn't it? So preparation of artificial fibers, that rayon, sodium hydroxide is used. These are the uses. Okay, understand? So how it is formed? Which process? Chlor-alkali process. Sodium hydroxide is formed at cathode or anode? Cathode. What is the process called? Chlor-alkali process. What is the brine solution? Just remember, what is the brine solution? Recollect, what is the brine solution? Yes, aqueous sodium chloride. What is the brine solution? Aqueous sodium chloride is called brine solution. What are the formed in the chloralkali process? Sodium hydroxide, hydrogen gas, chlorine gas. We'll go the uses one by one. Okay. Yes, we'll continue with the next gas, that is hydrogen gas, that is formed in the chloralkali process. We will see what are the uses of hydrogen. What is the formula of hydrogen? H2. Good. Is it a gas? Yes. So now these gas are stored in the cylinders. These are the hydrogen cylinders. Okay. So what is the formula for it? H2. Okay. Now where it is formed? It is also formed at the cathode in the chloralkali process. So earlier cathode, what is it formed? Sodium hydroxide. And this is used in the preparation of margarine. You have to tell me what is a margarine. Okay, you have to search this word and tell me in the next class about the what is meant by margarine in your worksheet. Then we'll see the uses. It is used as a fuel. That means like your LPG or CNG. Hydrogen is also used as a fuel. Okay, and it is highly combustible gas. It catches fire very easily. Highly combustible, that means it catches fire very easily. Okay, and it can burn. Okay, and it is used in the preparation of ammonia gas, NH3 by Haber's process. Okay, in the ammonia preparation, this hydrogen gas is also nitrogen combines with hydrogen gives the ammonia gas. Okay, and in the preparation of so many fertilizers, what is the use of the fertilizers? The farmers use the fertilizers for the good growth of the plants, isn't it? Okay, used in the preparation of fertilizers, and it is also used in the preparation of hydrochloric acid with chlorine gas. Okay, this H2 gas combined with this chlorine gas, already you all might have learned in this lesson, isn't it? How the HCl is formed by hydrogen plus chlorine gas, both combined to form a hydrochloric acid. Okay, hydrogen or hydrogen chloride gas. Okay, when it aqueous, it is an hydrochloric acid, isn't it? So in the preparation of hydrochloric acid with chlorine gas, hydrogen is used. Now next gas. What is the next gas? The chlorine gas. Okay, we will see the chlorine gas uses. So it is also, as it is a gas, it is stored in the cylinders or tankers. Okay, as chlorine gas is very dangerous. Okay, it can even kill you also if you breathe for some time. If you breathe for some time, you will feel breathlessness and you will immediately die. So chlorine gas is a very dangerous gas. Okay, and it is formed at a anode. Okay, anode in the chloralkali process. Okay, anode means positive end, cathode means negative end or negative electrode. Okay, here anode means the positive electrode. In the positive electrode, chlorine gas will be collected in a cylinders. Okay, so what is the use of this chlorine? You might have see the GVMC, the smell of the GVMC water or the municipal water, isn't it? It will be chlorinated water to purify the water. Okay, or to treat the water, to kill the germs. This chlorine is used by the GVMC or municipalities. Okay, to purify the water, and in the water treatment plants, chlorine gas is used. Okay, and to kill the germs in the swimming pools, and okay, this chlorine gas will be used. You will get this smell while the swimming, isn't it? Those who know the swimming, they can understand very easily. And in the preparation of PVC pipes, have you heard already? This also is a artificial fiber you learned in the PVC, polyvinyl chloride. Okay, this chlorine gas is used in the PVC pipes. Okay, water pipes, plastic water pipes, PVC pipes. Okay, in the preparation, the chlorine gas is used, and to kill these germs, it is also used as a disinfectants. Okay, and in the preparation of chlorofluorocarbons. Okay, and in the preparation of chlorofluorocarbons, this chlorine gas is used. Okay, and in the preparation of pesticides also, it will kill all these pests, okay, or white ants and all these pests. It will kill this, it has a capacity to kill, so it is used in the pesticide. So you all learned? Have you learned? Yes, good. So what we have learned in this, use of sodium chloride, sodium hydroxide, hydrogen, chlorine gases, and the families of salts. Have you understood well? If you got any doubt, you can call me by phone number, or you can ask me doubts in the WhatsApp. Okay, don't forget to write the worksheets. Okay, all of you must submit your worksheets. Understand? Okay, bye.